Okay, so in this video I'm going to talk about how to add values to a linked list in sorted order and how to remove values from a linked list. Okay, so let's go ahead and get started. Okay, so for this example, I have a class called numberList. I have a constructor, or actually I have a struct in the numberList for the node. This is how each node is going to be, or each link is going to be created. Here we have a pointer to the first address of the linked list, which will be head. And in the constructor for numberList, we initialize the head to null because we don't have any values yet. This class will contain the operations we need to use the numberList, right? So it'll have a method to add a value, it'll have a method to remove, and a method to display the values. And then at the end, we'll test it out in the main. Okay, so first of all, we'll have the node pointer, we'll call it H for head, and we'll initialize it to null. Right, no address yet. We'll use our method called add. We'll add a value. In this case, we'll add the number 5. And if you recall from the example I showed right now, the constructor for each node takes the value. In this case, it'll be 5. And it has a pointer to the next node. Right? So we have a pointer here called next. Okay, so when we first start out, our list is empty. So all we really have is just this. So this is going to look just a pointer. Call it H. And it points to null. Right, but we're going to add the value 5. So we're going to check first to see if there's anything in the list. If there's nothing, then what we need to do is create a new node, with the value 5, and for next we're going to put head, so H. So then what this code is going to do, it's going to create the node, if you recall, our nodes look like this. If we draw a little diagram, we have the value here and the pointer next. Right, this is each node. That's what it looks like. So here we'll have 5, and our next is pointing to whatever head's pointing to. Right, so if you imagine that head was pointing to null, so our next, which is right here on the bottom, is also going to point to null. But we also need to reassign head so we can keep track of the values in our list. So we'll set head equal to whatever the address is for this new node. So this is the node here, so then we'll set head equal to that. So now we have at least one value in our list. Okay, so how does this look in code? Let's go back to Visual Studio and let's set this up. Right, so this is our add method. Here we had passed the value 5. Right, so our first scenario for the add is if the list is empty, then we add a new node. Then add new node. Okay. So then if head is null, then head is new node. Whatever value we assigned here, in my example I use 5, but since we have a method here, we'll use the parameter value. It is null. And the next here, oh, it's capitalized. Sorry about that. Okay. So now let's move on to the next step. Okay, so from our previous example, we were left with just, sorry about that, we were left with just this. Right? So that's what we have here. Now let's say I want to add now the value, let's say 4. Right, so I want to insert this but in sorted order. Right, so we know 4 comes before 5. Right, so keep in mind, again, the constructor for node is the value and the next pointer here. Okay, so in this scenario, we know that the 4 comes before 5. So if the value of whatever head is pointing to, so if head value, which is 5, which is right there, is greater than value, which in this case is 4, right? This is 5, this is 4. If that's the case, then we create a new node. We put the 4 in there, and the next points to whatever head was pointing to. And then we reassign head. So then we'll end up with something like this. So first let's create the node. Put a 4 in there. The next points to whatever head is pointing to. So in this case, head is pointing to this address in memory. So then now this node is pointing to the same address. And 5 was still pointing to null. Then we reassign the head. So then now head is pointing to this node. Okay, so let's go ahead and add that to our code. We're going to need to add this part now. Okay, so now either head is null or the value from head is greater than the value supplied. So from the parameter. So then maybe we'll modify this a little bit. So if the list is empty here, or the value in head is greater. If that's the case, then we need to put a new node and we need to put it before or overwrite what was in head to begin with, right? Because now we have a value that's smaller, which is what we did in the example here, right? Before head was pointing to 5, now we have a value that's smaller, so now it's pointing to the value 4. Okay, so the next scenario in our add method, what if we already have a list set up and we need to add a value between two nodes, right? So let's say I want to add the number, let's say 9. Right, so how am I going to do that? Well, to do that, you need to have two pointers, right? So we need node, and then the two pointers are, it's going to be called previous for the previous node, and we need one called PTR, right? So how do we use those? To initialize them, you have to set them equal to, here for instance, previous is going to be or set to the same address as head. So then previous is H, or I'll write the whole thing out. I'll write head. Then PTR, so this made one called previous, which is right here, and it's pointing to this. PTR is going to equal head next, right? So what's head pointing to, or what is this node pointing to? This is the next here, so it's pointing to this node here, 5. So this is PTR 5. Okay, so then once we have those two pointers set up, then we need to traverse through the list until the value of PTR is greater than the value supplied. So then the way that's written is going to be while, or we use a while loop to traverse through the list, while the value of PTR, so value PTR value, while it's less than the value given to us, or the value supplied. So it's this value here. If this is the case, then we move, or we traverse through the list. Right, so at the beginning in this scenario, PTR value is 5, and the value given to us through the method is 9. Okay, so is 5 less than 9? Yes, it is. So then we need to move previous and pointer forward 1. To do that, that would be previous is now the same address as PTR, and PTR now, this one is PTR next. Right, so here this first statement points to right here, and PTR next, which is pointing to the 8, is now here. Right, so then these are no longer there. So let me clean this up a little bit. Okay, so now that we moved our pointers, Let's go through the list now. Let's check the while loop condition. Right. So PTR value is less than value. So now PTR value is 8, but we still have 9. So 8 is less than 9. So then now we need to change previous and PTR. So then now previous points to this, and pointer now points to this guy. So we can get rid of these here. So then now we moved them over 1. Okay, so now PTR value is 10. And is 10 less than 9? No, this isn't true. So then we're not going to move through the list anymore. Now we need to insert our node here. So then this won't happen anymore. So now let me show you how to insert the node. Okay, so now we need to create a new node. We need to put the 9 in there. So then to do that in code, it would be new node. So that's 9. And then for the next needs to point to whatever PTR is pointing to. It needs to point to this guy. It needs to point right there. So then we have a pointer set up. So that's PTR. Right? But then to insert this link into our chain, we need to make sure that whatever previous is pointing to, whatever the next here is no longer pointing to the 10. It needs to now point to this guy, the new node. So then we do that in code with previous, next, and then we assign it. Right? So then that will set up our new link in our chain. Okay, so now let's add what we just did in code here. So this was our first and second scenario. This will be our third, else okay. Now remember we had created 2 pointers that we needed. We can actually create those here on top of our add method. So we called one previous and we called the other one just PTR. Oh, don't forget the asterisk. Right. So then we initialize these at the beginning or here at this point. So previous is head. They're the same address. And PTR is head next. Right, so that was this one for previous and this one for head. Okay, and then we need to loop or traverse through our list. So while PTR value is less than the value given to us, right? The value supplied right here. So while that's true, then we need to keep moving through the list and readjusting the pointers, moving them one forward, right? So previous is whatever PTR is pointing to. So that previous is now the same address as PTR. And then we need to move PTR over by 1. PTR next. Okay, so we're going to keep moving through the list. But what happens if we continue going through it and we reach the end? Right? What happens if we reach right here? Right? Do we want to keep moving through the list? No. Right? So we need to make sure that we stop our while loop from running once it gets to this point. Right? What if I wanted to insert the value 11 instead? Right? So then we need to add that to our while loop here. The while PTR is not null and the value of PTR is less than value. So then we'll add that to our loop here. So either way, if we get to the end of the list, or the loop breaks early because we found a value that's greater than PTR, then we're ready to insert our new node. So if you recall from the code in our example here, we build the new node, we put the value given to us by the method, or by the parameter, we connect, or we get, for the next, we get this value here, so whatever PTR is pointing to, PTR, and then the previous next, we set it to the new node. I meant here if, or the loop breaks early, right? Because this condition ended up not being true at some point, so then that's where the new node needs to go. Okay, so now let's move on to the removing an element in the list method. Right. So first thing we need to do is, what if the list is empty? Oops. What if the list is empty? Right, so how do we determine that? Well, if head is null, then there's nothing to remove. So then this method just will return, and since it's a void function, it doesn't return anything. So I can't put 0 here. I just return. Right. So this is the first case where the list, there's nothing in it. Okay, so the next thing is, what if, what if the value to remove or delete is the first value in the list? Right? So then that's if head, because head usually points to the first value in our linked list. So if head value is equal to the value given to us, then how do we remove it? Okay. So the way to do that is we're going to create, I guess, a temporary pointer, right? We can put that here on the top. So that's node, and we'll call it PTR. So it's temporary. We're going to use it just so that way we can delete the address. So we're going to set this PTR equal to head. Then all we need to do is reassign the head. So head is now going to be head next. And then finally, we just delete that memory location. So we use the delete command and we delete PTR. Okay, so this is what we initially did in code. Right, so we want to remove 5. Right. So what we did here was we created a pointer, PTR. We set it to the same address as head. Right, so we did this, PTR head, pointing to the same thing as this. We reassigned head to head next. Right, so what we did here is we overwrote this pointer. This here is head, right? Head is pointing to this, but head next is pointing to the 6. So then by doing this, now head is also pointing to 6 here. And then finally, we delete PTR. So whatever PTR is pointing to is now deleted. So now we have just this. And that's pointing to null. Okay, so now let's say we're not removing the first value anymore. Now we're removing something else, like let's say the 6. So let's remove 6. Alright, so now how are we going to do that? Right, well, we're going to need to traverse through the list almost the same way we went through it when we were adding a node in between two links. Right. So first of all, we're going to need our temporary pointer that we had created earlier. So PTR. We're going to need to point to the same thing that we're pointing to here. So we'll point to this value. So then while the value of PTR is not equal to the value given to us, then we need to traverse through the list. Okay, so just like the last method, we need to also keep track of the previous node. So we'll need another pointer called previous. So then we set previous to the same address as pointer, and we move pointer forward by 1. So PTR next. Right? So then that's going to give us this. So PTR is now here. Previous is there. Okay, so in this case, is the value of PTR is 5. Is that equal to 6? It's not. So then we're going to need to move through the list again, or move our pointers. So then now previous is going to be here, and PTR will be there. Okay, so let me clean this up. Okay, so now that we moved our pointers forward by 1, now is PTR value not equal to value? Alright, so PTR value is 6. We need to remove 6. So now this condition is no longer true. So we're not going to move our pointers anymore. So then we don't do this anymore. Okay, so now that we found the value, to remove it is pretty simple. What we're going to do is we're going to reassign previous next. We're going to assign it to PTR next. So PTR next. Right, so we're going to make this one point right here. Right, so previous next points there. And then we're just going to delete PTR. So then that will essentially do this. And we're not pointing to that anymore. So that's how you remove it. Pretty simple. Okay, so back to our code here. Right, so for the removal method, we ended up having to use an extra pointer called previous. Right. And then here, if the value to remove isn't the first one, then we need an else. Then we need to initialize this one to head. Right, that way we have something to check. Right. So while the value of PTR value is not equal to the value given to us, right? Because this is the value we're looking for, the one to remove, which is this here. So these are the same. So while that's not the value, then we need to move our pointers. So previous is whatever pointer is, and we move pointer forward over by 1. Okay, and just like our last example, we need to make sure that PTR isn't null. Right, because then that means that we reach the end of the list. Right, we don't. If we do reach the end, we don't want to move the pointers anymore. Now, let's say this loop does terminate early, and we find, let's say, a 6 in our list that we're trying to remove. Then that means that PTR is not null. Right? PTR has something in it. If PTR is not null, then that means something was located that matched our value here. Right, so if that's the case, then we need to unhook it like the way we did in the example here. We need to set previous next to pointer next. So previous next is PTR next. So we unhooked PTR from the list. Once that happens, then we're ready to delete PTR. Okay, so let's go ahead and test out our number list. So then we'll make a number list. We'll call it something simple, just like list. And we'll add some values similar to what we did in the example. So list.add. First we'll add a 4. Then we'll add a 5. Let's add, I think we did 8. And then finally we'll add a 10. Okay, and then let's go ahead and display our list. So let's go ahead and run that. Okay, so we have 4, 5, 8, and 10. Now let's make sure that we can insert a value between two nodes in the correct location. Right, so let's say I want to add the 9. The 9 is supposed to go between 8 and 10. So let's try that out. So we display it there. Then I'm going to do list.add, and I'm going to add the 9 after the list has already been set up. Right, we have 4, 5, 8, 10. We're going to display it. Then maybe I'll see out a message like add 9. And then let's see if it will add it in the right place. Control F. Oh, I need to display the list. List dot display again. Okay, so now let's try it. Okay, so we have 4, 5, 8, 10. Then we add 9. Then we have 4, 5, 8, 9, 10. Okay, so it works. Alright, so then now let's test our removal method. Let's go ahead and remove this 8 here, and then we should end up with 4, 5, 9, 10. Okay, so then let's see out. Remove 8. So then list dot remove 8, and then now let's redisplay the list. Make sure it'll display correctly. Okay, Control F5. Okay, so we add 4, 5, 8, 10, then we add a 9, 4, 5, 8, 9, 10, then we remove the 8, and then we end up with 4, 5, 9, 10. Okay, so I think that will work, and that should be it for the video. Sorry it was a little long, but I hope it was informative. And of course, if you have any questions, you can always email me. Thank you very much for watching.